Hello everyone, welcome back. I'm going to redo the exact same question. I'll say it a bit faster this time because we know the question. We've got 15 balls, 5 in 3 different colors. I'm going to pick 5 at random. What's the probability of those in that group of 5? 3 of them are going to be green. So if you want a quick reminder, this diagram was what we started off with, 5 of each color, taking 5 at random, and of the 5 at random, what's the probability of 3 of them being green? The only difference, I'm going to solve it in a different way. I'm going to teach something that's called the hypergeometric distribution, and the formula for it is called the hypergeometric distribution formula. And this formula is for this type of question where you have a big number and you're taking a small number out. What's the probability of that smaller sample having a certain number? If I just make up a question, we've got 20 people, 13 are adults, 7 are children. We take 3 at random. What's the probability 2 are adults? Same concept. Or you could have coins, nickels and dimes. So many nickels, so many dimes. You take a group of so many. What's the chance of having 2 dimes or whatever? And this is the formula. And what it is, each letter has a meaning. That big N is how many altogether. In our question, it's 15. We had 15 balls. The little n is the sample size. If I remember, we picked 5 at random. That's 5 balls. The big K is a number of successes. They call it successes because it's a general formula. Here we're dealing with balls. Another question could be dealing with coins. Another one could be anything. It could be marbles. So in this question, success refers to a green. There are 5 greens in the entire population, and then what they call the general words they often use successes. In this case, green in the sample. There'll be 3 greens in the sample. So what we do, we just plug these numbers into this formula. See this big K on top, small k at the bottom, big 5, 3. Big N minus big K, 15 minus 5. That's the big N, and that's in big K, and everything else plugging in. Small n minus small k is 5 minus 3, and at the bottom, big N over small n, population size divided by sample size, 15.5, and I just simplify. The only thing I do between these 2 steps is I simplifying what's inside this bracket. 15 minus 5 is 10, 5 minus 3 is 2. And what you notice, this is a paper I used a minute ago when I was solving in part 1. That is the exact same formula which I had in the other question. You're still stuck with my horrible handwriting either way. The only difference is there I explained why we're doing each step. Here I just plugged in the formula, but we land up the same thing. So what I did before was explaining how this formula derived. And now we just simplify exactly like in part 1. Like 5 choose 3 is 5 factorial, divided by 3 factorial, 2 factorial. And as one example, 5 factorial means 1 times 2 times 3 times 4 times 5. And the same concept with each one. And when we simplify, just like the previous question, we land up with 0.15 to 2 decimal points. And that's the answer using a different method. And thank you for watching.